All right, so open Rhino. Set your units for like inches, feet or inches. All right, so the assignment asks us to make a solid cube 4 inches by 4 inches. My computer is a little slow this morning, I'm sorry. All right, so here we are. I check my units. Let me do this again so you see how we do this. Go to the box command. Again, if I hold this down, I have all these solid options. All right, so I'm going to start with the box. Click here, 4 inches, 4 inches, 4 inches. And I'm going to change it to cyan. Okay, now I want to make some other shapes to carve out of this with. So if you go into the wood shop and use a chisel, using the shape of a chisel, or sometimes in construction, this is the equivalent of like cast concrete. If you need to embed a guardrail or something into concrete, usually when you're pouring the concrete, you put like a little sleeve to leave a void in it, and then you just kind of slip the handrail in to support it. So basically we're going to be, you could think of it as carving out or as, leaving space for some other object. So a few things to try. Try like spheres. So try a sphere, and it'll ask for the midpoint, the center. So I can click here and go like that. Again, it asks for 6, at least 6. I'm going to do this a couple of times. Play with the size of these things. That one's probably too big. Let's do it again. That looks pretty good. All right, so you saw what I did there. Just doing spheres. We're going to start with spheres. And now we're going to type the command. Make these red. These are going to disappear in a second.
How many should we do?
The assignment says 6.
6? All the spheres?
Nope. I'm just going to start with spheres. I'm going to show you the problem with spheres. So let's start here. So type Boolean. If you type Boolean, you get all these different options, right? So let's try Boolean union. See Boolean union? So select surfaces or poly surfaces to union. This one, this one, this one, and this one. Okay, now these are like merged as one single solid. So it's another way when you're 3D printing, if you've got a couple of objects, you really want to, you can either join a bunch of surfaces, or if they're all solids, do a Boolean union. I'm going to undo that and type Boolean. Boolean split. Let's see what this does. See what it did? So Boolean split, it made this a separate piece, and it made all of this. Everywhere there was an intersection, it made it its own individual piece. But again, they're all solids. Like these are not, you could 3D print any one of these. I don't know why there's 2 of those. See, so it starts to make all these wedge shapes. Everybody see that? I just want to show this. But this is not what you're going to do, but I want to show you the different options. So play around with the Boolean tools, and sometimes it's useful to quickly, instead of going in and trimming things, if you're working in solids, try some of these settings. Try the last one is Boolean intersection. Is that what we just did? See that? So that was Boolean intersection. So everything that was overlapped, it kept, and everything else it got rid of. Just like the difference between trim and split. If I split a line, it keeps both pieces, but it splits them. If I trim, it gets rid of one end of the line. It just leaves the remaining piece, right? But look, that already looks like a somewhat complex form. And the last one I think that you're really going to use, you could do that one, the one we just did, which was Boolean intersection. But try Boolean difference, and you can do them one or two at a time. So select surfaces or polysurfaces to subtract from. We're going to start with the cube and click enter. We're going to select with these. Okay, so I carve that out. You can do it again. Do it again. Enter. Enter. Okay? We only use 3. And you get interesting shapes and conditions when your shapes that you're subtracting with start to overlap one another. Like if I just do this, and I make all of my spheres if they don't touch, there's going to be nothing unpredictable about this. So what I like are like multiple overlaps. It will give you a little bit more complexity, but for instance, subtract from this, I can actually do all of these at the same time. So, okay. There's nothing wrong with it. It's fine if you want to do that. Try to overlap a couple of them, and you'll see that you start to get some weird, you know, curves like that and things like this. Okay. Pamela? Barbara? What's wrong? Why do we not necessarily want to do this?
We can literally cut and do it.
Yeah, it's gonna be hard to unroll a section of a sphere. Remember, we have that problem, like, you know, to flatten an orange peel, you have to tear the orange peel and it gets all distorted. So you can do this, and a way to fabricate this easily is to 3D print it. It's no problem to 3D print the shape. But to explode this, and then try to laser cut that piece, it's going to be hard. You'll have to use the smash command and try it. Again, try it if you want. But what I would recommend is that you use a variety of developable shapes. So what are some developable shapes? A 2D shape.
Pyramid.
What's a solid? A pyramid, yeah, triangular pyramid. Cones, I really like cones. Just roll up a cone. No folding necessary. Let's do a cone, a pyramid, some of the other shapes. So let's start again. So here's a pyramid. Center of the inscribed pyramid. Yeah, so that would be a good one to Boolean. Let's draw a couple more. Cylinders. Let's draw a couple more. I like cones. There's a truncated cone and a regular cone. A truncated cone is just, there's a top and bottom radius. See that? Let's draw a few more. Javi, how many shapes are we supposed to use?
6.
So a combination of these things. And you might try like playing with the direction. So I think I should be able to make a cone. Like one thing I can do is move this, and then I can rotate it into place. Right? I can use my 3D rotate. You know what? Let's rotate 3D. I should really mirror this. So I could Boolean that out of the center. You won't see it because nothing is, it's all going to be concealed. So let me see if I can draw a line from the middle. All right, so play around with some shapes like that. Okay? Get a couple more in there. All right, so starting with that, Boolean difference, let's subtract from here. All right, we get that. Now we have this, and it's easy to unroll and flatten all these shapes. That one's weird. That's a weird condition. But anyway. Does somebody have a question? No? What?
Are we gonna do this in the 3D printer or laser cut?
Both. Don't you want to?
I would rather 3D print this.
You want to just 3D print?
That'll be sure.
If you want, let me pause the recording. Okay, I'm going to post these commands and do a good job. I try to make them interesting. If you're doing, if we're just going to 3D print, there's no reason we couldn't do something like this, or, you know, or like we could add a sphere to this. But do it knowing that you're not going to be able to. Let's get rid of this tube. Let's add a sphere over here. You know, you wouldn't necessarily be able to easily unfold and unroll this thing. Okay, so let's re-Boolean this. Subtract from this, enter, subtract with these. I feel I took out too much. Let's make it smaller. Smaller sphere. Why can't I delete? All right, so one more time. Enter, select these, and then click enter. Okay? So I kind of like this shape. It's like a curiosity of voids. All right, so I'm going to take this. All right, I'm going to put the original cube back on it, just to illustrate what we're doing here. And I'm just going to duplicate. If I don't want the solid, I just want the lines. How can I get the lines? Franca, how can I just get the lines from this? I can go I can type duplicate border. No borders duplicated. That's because it's a solid. So let's explode it first. Now let's do duplicate borders. Now I can just come. So it gave me those. And now I'll do it again for the bottom one. Give me those. And now I can just delete these again. And I basically will have the curves. I can come back and draw the lines. I want to have these just so you can see where the original cube was and then what we've taken out of it. And I think this would be a good idea for you. Okay? So ordinarily we're done. And this is what you could just, unroll and laser cut or 3D print. But again, if we look at an axonometric, really what you're doing is, it's called the picture plane. You're rotating a certain degree, and you're projecting the three-dimensional drawing on it. But there is no perspective in it, per se. So that's what happens when you set, these different angles of your plan, when you rotate your plan in relation to the picture plane. And it doesn't seem like that's what you're doing, but that's what you're doing. It's called projective geometry. So you've all, it's good that you all have done these a little bit. But you see the plan obliques at 90%, you get an axon like that, which doesn't really show you the 3 dimensions. Here's a 30%, here's a 45, and usually a 30, 60, 90 is a good way to go. So just for reference, we won't go too much into the discipline of that drawing, but let me show you how to do like a workaround in Rhino to get a proper axonometric drawing. And again, Rhino is not an architecture tool, it's just a 3D modeling tool, it's general. Jewelry designers use it, toy designers use it, and these are people who are not really concerned with plans, sections, elevations. We ultimately are concerned with those things because, and I would say, it's better to take a strange shape or something you've made and present it in a very conventional format, and then you really understand how strange the thing is that you've made. But some of you are going through this at your desks and desk grids. You'll 3D model a strange thing, and then you won't show it either in plan, section, or elevation. And it's really impossible to talk about because we don't know what it is that we're looking at. Like I have to critique a project either in section or plan or understand what it looks like as a form. And so these are more like conventionally clear ways of representing your forms and your design. So what we're going to do, we have to follow this. I didn't write this, I found it. Because Rhino is not, there's no axon button. So there's a workaround, and I'll upload this to Canvas and read through it. Right? It says there's no way to create a real-time 3D axon view that's geometrically correct, as axonometric isn't really a true 3D display, but rather an artificial pseudo 3D construction. Okay, so it's possible. The procedure is simple. So it's really these 5 or 6 steps. 8 steps. Okay, 9 steps. But it's fast. All right, here's what we're going to do. So it says export all the objects you want to use into a new Rhino file. I have found I don't think you have to do that, but let's try it. So this is what we want to make an axon of. Let me save this. All right, I'm going to export that by highlighting it, going to export selected. Okay? Okay, I'm going to type axon model exported, and I'm going to export it as a Rhino. All right, so now I'm going to minimize this. I just left it as a Rhino because we're not exporting DWG. We're just going to open the Rhino file without all the other stuff because it tends to distort like everything in the drawing. So I'm gonna come down here to the Boolean exported and open it up again. You'll see why it says to do that in a second, and you might as well just follow this cookbook. Okay, here it is. You see nothing else is there. So we exported it. All right, so we did the first step. First two. All right, make sure you're in a 4-view mode and you zoom all extend, so let's do that. Okay, I double click, I get the 4-view mode. And then zoom all extends, I can either select that and right click on my magnifying glass and get it in all these viewports. You see that? And I'm just going to make them all ghosted. I like ghosted. Okay, next. In the top viewport, we want to rotate everything to the axonometric angle. So we could do 45, we could do 30. Let's do 30. Okay, and we also may want to move this to the origin. So how can I move this model to be on the 0, 0? Hunter? Well, I have a question for you. How do I move this to the origin? A quick way to do that, I think there's actually a command, but a quick way to do that, because often commands, we forget the command and then we waste time Googling it. Just type polyline. It's going to ask you for the start of the polyline. Just type 0, 0, 0. Okay, now it's connected there. And then just come connect it over here. And now just grab this and move it from here to here. I think there's a command like called move to origin or something. But now it's on the origin. This is my 0, 0 here. Hunter, what's your question? What do you mean? It's up to you. I think you should do it. It's not more work, but it'll be useful, I think. So yeah, keep it. And let's see what happens. All right, so it says in the 4 viewport, we're going to rotate it 30 degrees. Okay?
What happens with the isometric view? Because I was looking through the views. When you press set view and it has one that says isometric, does it change or something?
Okay, I rotated 30 degrees. Now I'm going to answer Barbara's question. You mean here?
Yeah, when you go to set view, there's an isometric.
Yeah, so these, look.
I don't feel that changed.
There.
It worked?
So what it does is, I unrotated it, so I'm playing still like this. So it basically looks at it at a 45. So it's pretty close to it's really a 45 degree like axonometric view. You see the problem with 45 axonometric views, like the corners line up and sides are equal. They're correct. That is a correct rotation, but I think 30, 60, 90 is a little bit better. So another workaround for this would be to do that. And then maybe rotate this. So I'm just going to do 2D rotate. Just rotate. Type here and type 30. It's pretty close. So it gives you a completely parallel view. So the verticals are parallel, the horizontals are parallel. There's no perspective in it. You may be able to figure it out doing it this way. But try to follow along. And again, if you do north, northwest, you know, these are all the four corners. So looking at it from the four corners. Okay, those are the different corners. You could do this. If you want something other than 45 degrees, try to follow this process. Apologize, my computer is slow. Let's just do 2D rotate. I'm going to select the origin and type 30. And you can play around with this, all right? And for the purposes of this exercise, I want you to do this because this is a pretty cool process because it leaves you with a distorted view that I want you to 3D print, which is kind of nice. Okay, next step. While the model is still selected, go to the transform menu and select the command shear. Okay, so we're going to select it, go to transform and type shear. Click on shear. All right, it's asking us for our origin point. Let's see what the PDF is telling us to do. You have to play around with this a little bit. To establish the baseline, you need to indicate 2 points in the right viewport. You want the baseline to be vertical, so these 2 points need to be vertical to each other. Easiest way to do this is select the origin, and with ortho on, select any point above it as the second. All right, so you need to just draw a vertical line to establish the baseline. All right, so what's the origin point? We can select here, and then in the right viewport, we can draw straight up. Then it asks for a shear angle. We're going to do negative 45. Negative 45. Okay, so look, see in the top viewport? It looks like an axon, right? And then look in the 3D viewport. It's distorted the model, which is great. This is really cool because you'll build this, and then it looks all weird, and then when you look at it straight up and down, it looks like an axon.
Oh, you have two models?
Yeah, you'll build this. You'll build this as a distorted axonometric model. Yes? That's what you're 3D printing. You want to make the other one too? Now that we're just 3D printing? It is, come on. It's 30 seconds more work. Why don't you do both? Look at them side by side. I think it would be cool. Or we can laser cut this.
No.
Okay, sound good to everybody? So you'll have this. Let's copy this. So you have this and this.
Well, that's all?
That's it. They're 2 inches. To 3D print, they were going to be 2 inches. Okay? They shouldn't.
How long do you think it will take to 3D print?
I think it will take you like 1 hour or maybe 30 minutes or something. All right, so we're going to have this. Everybody agree on that? Valerie? You agree? Valerie agrees. Anybody disagree? Yeah, Valerie, do you have a question? How to do the AXA? I can. And in addition to that, I'm going to upload this handy tutorial. Again, I like it. Okay, so then if we wanted to just make a drawing, for instance, guys. So now it says, use the make 2D to make your 2D line geometry. So if you ever have a form that you want to make an axon, which every architecture instructor will give you like kudos for making an axon, and we'll kind of boo you for just giving us a random 3D view. It's hard to select the best view. So unless you're really picking like the view that shows the best part of your project, like an entry and perspective or something, if you want to show it as a 3D, try the axon. It's a good way to represent the form. So what you do in this case is you come back here and you look at this thing in the top viewport, and I would select the whole thing, and then you do dimension, make 2D drawing, right? Which is also, I'm going to put it right here. See? So here's your axon drawing. Make sense? Valerie, did that make sense? I'll show you how to shear and distort the thing again. But then you take these curves, these lines, and you'll export to AutoCAD and do the line weights and print them out. Does that make sense? And if we didn't have these, it would look like this.
You also selected the hidden lines?
Yeah, we should turn the hidden lines on. That's true. Let's do it again. I usually always have that set to show because they're on separate layers and you can just turn them off. Okay? So if we delete these lines that Hunter doesn't want to draw, there we go. Okay? Make sense? Everybody can do it? Basic procedure, but I think a useful one. And let's use it as an opportunity to learn to 3D print. It's a pretty simple thing. So if you can 3D print the original and the distorted one, we'll put them side by side. What time? So for those of you watching this class from home, if we want to test it out again, we've rotated these elements, again, 30 degrees. Right, so let's do that one more time. Rotate 30 degrees. And you can play with that. You could rotate it negative 30 degrees, 60 degrees, whatever it is. And then we're going to go transform. We're going to use shear. And then our base point, we want to do it in our right viewport. We just want to draw straight up. And then the shear angle is negative 45. So the other thing I can do is do the shear command again. Origin point is here, straight up. What if I do negative 30? All right, you see a slight difference. So it didn't shift it quite as far. Now this is a 30-degree angle instead of 45. Yeah? So if I put these next to this, you'll see a more incremental, like this would be like an in-between version. Again, you see the problem with not grouping. It's a lot of different lines, so I'm going to group everything. And I'm going to rotate this. All right, so you see that? So 0 shear, 30%, 40 or 30 degrees, 45 degrees. I can do a 15 and do an in-between one also. So you can play with that if you want. But if we look at these in the top view, yeah, we get something like that. Which if we shade it, yeah, it looks like that. So again, it's really easy to just kind of make 3D stuff. But what I want you to be a little more disciplined, try to carefully construct things, type in angles, use rules. That was the point of that rule drawing. The more deliberate you are about using rules to set up your model, the more you can interact with it. And we could come and say, you know, why don't you not shear it as much? And it would be easy to just change that parameter. But if you've sort of just organically modeled this thing, it makes it tough to interact with it. And often what will happen with you, everyone experiences this, but so no shame, but try to avoid this. You'll get next year, the year after, you'll get pretty intuitively adept at Rhino, and it'll be like the midpoint, the mid-review. You'll get this big complex 3D model. You're just adding all these things. And then after the mid-review, you'll need to like adjust it a little bit, and it's hard to know exactly where to go in. And I would say there's a virtue in just redrawing things, like tracing things, like we did in the Labyrinth project. And if you've got a step-by-step process, I would just remodel things completely. And you won't want to do that because it took you an all-nighter to finish a 3D model. And then when it comes to drawing sections, you're just going to use the slice command. And that's not a real section. I would even encourage you to just draw your sections. And be very deliberate about the drawings that you put up on the wall. So don't just give us 3D stuff. It doesn't make it good because it's 3D. And it doesn't make it good because you digitally fabricated it either. But it's important you know these skills, and that's what I'm trying to show you here. So let's do one more step, which is if I want to 3D print this, the first thing you need to do, and I can, why don't I add the step-by-step shear command PDF to the canvas, so take a look at it, and then I'll type at the end of the assignment the steps to prep it for Rhino. And the first step, save your file, but the first step is to select that thing and go File, Export, Selected. And then does anyone know what file format we need? We need STL. What is STL? Stereolithography. So stereolithography is the process of slicing the solid. Like the technology for the 3D printer, it's not different than the 2D printers. It's the same print heads basically, except instead of printing out ink, they're printing out melted glue. And as soon as it prints it, the glue solidifies. So it's like a hot glue gun nozzle. But it's really only printing one 2D slice at a time, and then the bed lowers and it prints another one and then it does that. Yeah. So it's not more complicated than that, but let's export as an STL. It's down here. See, stereolithography. All right, so we'll do export Boolean STL. And just leave all this default. You can go to detail controls, but I would just leave it all at its default settings for now. All right, so now I have this file here. Oh, for gosh sakes. Is it here?
Do we need to download another program to use a 3D printer?
Yes. And it is called, let me see if I still have it. Here's the next thing you got to do. Start with that, then go to MakerBot. You need to download something called Makerware. Okay, we have Z18s are bigger. We've got 4 Z18s at MBUS. So if you ever want to 3D print something larger, go to MBUS. But the typical ones we have are these, they're called MakerBot replicators. They're like $2,000. When I was teaching at MIT, we bought one of these machines, and it was $300,000. But so you can see like the technology, I've seen these for sale at Home Depots. Sometimes they'll do a promotion, they'll sell them at Home Depots. They're less expensive than your computer, although maybe not as useful, but some people like to play around with them. There's a website called Thingiverse. Has anyone been to Thingiverse? And Thingiverse, you can download, usually for free, 3D print-ready files. Like for my kids' school, they'll be like, Dad, can you 3D print us a shark? And I'll 3D print them a shark and then take it to school. Beyond show and tell, it may not be that useful, but there are things like you can download iPhone cases.
Can I do my iPhone case here?
Yeah, look. See?
Yes. Oh.
3D print that iPhone case. Actually, I need an iPhone case. Yeah? So here it is. So you can 3D print that. There are some useful things, and these are all free generally. So you can download it, open it, and then send it. But let's go back to this. Guys, for Monday, I want you to have started this. If you're all going to, my worry is if you're all going to 3D print, Monday. These will not be done for Wednesday. Let's say that's okay with me. Turn in the drawings on Monday, and then try to get 3D printed by Wednesday. But Wednesday, I'm going to introduce the next exercise. Okay? There's no reason for us not to have class waiting for you to 3D print. All right. So get these drawings done. They're really fast. Let's do the make 2D drawings of the axons. A few screenshots. Yes, Hunter? Yeah, that's what I'm going to show you now. But get the drawings done. So in the meantime, try downloading this. I think you need to go to support, and go to software. Download MakerBot Print 4.3. I have Windows. Let me see how long this takes to download. You know what? Let's wait 1 second. I think we can just do this whole tutorial right now. I'm going to pause while it's down.